Hi, Assalamualaikum warahmatullahi wabarakatuh, and good day to everybody. We meet again in BHA1113 Engineering Materials. For today, we are going to look at on Chapter 1, which is Introduction to Material Science and Engineering. For the chapter objective for today are include explain and discuss the material science and materials engineering, understand the relationship between structure, properties, processing method, and performance of materials, differentiates the types of engineering materials and give examples on their current and future application. And the last one is material selection and design for sustainability. Whereas for the lesson objectives for today is that analyze and illustrate the materials atomic bonding and crystal structure. As for the topic for today, we are going to look at on the introduction to material science and engineering. Number 2, we are going to look at on the classification of engineering materials. So, as mentioned to you before, there are relationship between structures, properties, processing, and performance of the materials, whereby with the understanding on the structure, composition, and properties of the materials. Later on, we're going to look at on the processing, which affects the performance of the materials. But before that, let's look at the evolution of materials, whereby it started from Stone Age with the materials exist during that day, as that was that stone, wood, clay, and so on and so forth. And then it moves to Bronze Age, Iron Age, or also known as Industrial Revolution. And finally, until today, the materials that we can find is that nanomaterials. So right now is actually nanomaterials age. And as mentioned to you in the previous lecture is that there are differences between material science, materials engineering, and MSc. However, the one that you are going to learn is material science and engineering, whereby it is resultant knowledge of the structure, properties, processing, and performance of engineering materials. So in general, material science is a basic knowledge of materials, and materials engineering is actually the applied knowledge of materials. So in material science engineering, we combine with these two elements, material science and materials engineering. So why do we need to study material science and engineering? This one, we need to learn material science and engineering so that we can select material to be used based on its cost and also performance. Other than that, to understand the limits of the materials and to be able to create new materials that will have some desirable properties. So in general, all engineering disciplines should know the basic knowledge of engineering materials. Otherwise, it is very difficult for us to come out with a final product which meets the which meets the customer's needs. And in material science and engineering, there are structure of materials that we need to learn and we need to know. Is for the structure materials, there is atomic level and also microscopic level. For the atomic level, the arrangement of atoms in different ways. This one will also be covered in this subject, which is in the other topic. Microscopic level refers to arrangement of small grains of materials that can be identified by microscopy. So you can see examples of materials in the slide here, for example, carbon and also aluminium oxide with different structure of materials. Properties are the way material responds to environmental and external forces. For example, mechanical properties, electrical and magnetic properties, thermal properties, optical, chemical, stability. So all these properties actually will affect the final product of the materials. And different types of materials will have different types of properties. And therefore, we need to know what types of materials that we are going to use for different types of product. And there are relations between structure, properties, and processing relationship. For example, processing and performance. In materials engineering, it uses processing and performance to design the structure to achieve specific properties of the materials. Whereas in material science, it uses structure and properties to investigate the relation between structure and properties of the materials. So basically, the flow for this part is it starts with processing, followed by structure, and then properties, finally, the final performance of the materials. Let's take example of cake making. On how do we make cake. So we know that to make cake, we need to have a flour, sugar, butter, and so on. And if you don't mix well the ingredients, the texture will be weird, a bit weird. It might be turned into biscuit instead of cake. So the mixing process itself is known as processing, and the texture is referring to the structure. And the final part is that the properties. Before the final part is the properties. Properties means the cake itself, whether it is in dense or it hard or it is too soft. So it is properties. Then finally performance, which means the cake is either good or not good in terms of its own taste. So that would be the flow for structure, properties, processing, structure, properties, and also performance. Number 2, same, which is cake making. So if you see here, instead of mixture, another part for baking a cake is that we are going to expose it to heat. So if the temperature is not enough, if not good enough to bake the cake, then the cake might be turn out to be solid, which is too hard, or it changed to be liquid-like in terms of its structure. So you see the process of baking itself, whether mixing or introducing it to the heat, it is known as process. After that, the structure, which is either liquid-like or solid, it is known as structure. And then dense, which refers to the properties. And finally, the taste, whether the cake is good in taste or the other way around. Okay, now let's move on to classification of engineering materials. You see, different types of materials has its own classification. For example, metal and alloys is classified as crystalline materials with metallic bonding. Ceramic crystalline materials, ionic bonding. Glass, non-crystalline materials with ionic bonding. Polymers, non-crystalline materials with covalent bonding. And composite, mixture of the above materials. And semiconductor, which is unique electrical conducting behavior. Well, in general, the top classification, the top common materials that you are going to learn is that metal alloy, ceramic, and polymer and composite. That would be the most common types of materials. And as for the application, you see, for example, a car. To produce a car, they don't use only metal or steel. They use a combination of different types of materials. For example, aluminum, plastic, ferrous, and so on and so forth. And finally, they will come out with a car. So to produce a certain types of product, normally we always use more than one types of material. Now let's look at the definition of each types of materials. Number one is metals and alloy. What is metal and alloy? It is actually an inorganic substances which composed of one or two metallic elements. It may also contain non-metallic elements. Its properties is crystalline structure with good thermal and electrical conductors, strong and ductile at room temperature, good strength at high temperature, shiny when polished. As for the classification, ferrous metals and alloy, non-ferrous metal and alloys. So in metals, there are ferrous metal and non-ferrous metal. We'll see these differences in the next chapter. Example of metals and alloys include iron, copper, aluminium, nickel, and titanium for metallic elements. For non-metallic are carbon, nitrogen, and oxygen. If you refer to the periodic table, those elements that are inherently metallic in nature are shown in color. Example of metals and alloys include in automobiles like body, chassis, spring, engine block, and so on and so forth. Structure, you may find it in building, bridges, airplane. You may find it in engine component, fuselage, landing, trains, machine and machine tools, electrical wiring, and so on and so forth. So there are many applications which can be found for metals and alloys materials. Number two is ceramic and glass. Ceramic and glass refers to inorganic substances, consists of metallic elements and non-metallic elements chemically bonded. There are usually combination of metals or semiconductor with oxygen, nitrogen, or carbon. The properties include crystalline, non-crystalline, or mixture of both. It has high hardness, high temperature strength, brittle, lightweight, high strength, good heat and wear resistant, reduced friction, insulative properties. And if you refer to this periodic table, ceramic compounds indicated by a combination of one or more metallic elements in light color with one or more non-metallic element in dark color. Example of application for ceramic is listed as follow, like electric insulator, abrasives, toilet equipment, pipe insulator, pottery, and so on and so forth. So these are actually examples of products that can be found in the market. But of course, there are hundreds of other applications which can be found. Number three is polymeric materials, whereby it consists of organic long molecular chains or network. Its properties is that most are crystalline, some are mixed, has very strength and ductility, poor conductors of electricity, very good insulator, low density and low softening temperature. Polymer has its own classification, like plastic. In plastic, it has thermoplastic and thermoset. And the other one is elastomer, which is soft in nature, and plastic is hard in nature. Well, you see, plastic is actually an alternative name of polymers because of their extensively formability during fabrication, and there are synthetic, which means human-made, which represent a special branch of organic chemistry. Polymers very attractive with its lightweight and also low cost. So the one with the color is actually commercial polymers. Examples of polymers are listed as follow, like packaging, containers, adhesive, roofing panel, construction, electronic, and so on and so forth. Number 4 is composite. Composite is a material which is made up of two or more distinct materials. Its properties is that combination of properties that is not displayed by any single material. The reinforcement is usually stiffer than the matrix, thus stiffening the composite materials. For example, concrete, fiberglass. Yeah, and composite has various types, which are PMC, MMC, and CMC. PMC, polymer metric composite, metal metric composite, MMC, CMC, ceramic metallic composite. So examples of applications like fiberglass, F1 sport car, helicopter rotor, carbon fiber racing bike, and so on and so forth. Other than that, yeah, you may find component in a part, component or part in the whole product for vehicle and aeroplane. Last but not least is electronic materials, which is semiconductor. It has unique properties which are capable to alter electrical conductivities to their surface chemistry in very localized area. The conductivity is as good as metals because no free electron and the electron valence is full. What is electron valence? All these things, no free electron and electron valence, this will be covered in chapter 2. And if you refer to this periodic table, the one with the elementals of semiconductors are in dark color. And those elements that form semiconducting compounds in light color. The semiconductor compounds are composed of pairs of elements from columns 3 and 4 or from columns 2 and 6. You see, different types of materials have different material strength. So if you refer here, the highest strength would be in metals and alloy, and the lowest strength would be polymer. So this classification of material strengths you need to know and understand, because different products may require different strength, and therefore you need to choose correct materials to produce that product. This one is material production over the years. If you look at here, the one with the highest production was steel. So you can imagine what would be the cost to produce steel over these years. So this one also the same, engineering material usage over the years. So the one that being preferred to be used was steel as compared to other types of materials like iron, plastic, and aluminium. For the cost analysis, if you can see from this table, the highest cost of the materials would be for brass. So you can imagine how difficult it is to produce to produce a processed brass, because if you look at the other profile, the other graph, you see different materials with different types of processing method will produce different types of costs. Some normally the more difficult it is to be processed or to be produced, then the higher the cost of that materials sold in the market. And to summarize again, the material selection process will start from picking up the application, whereby we need to determine the required properties. After that, we need to identify the candidates materials, which include structure or composition, and then the processing, identify the required processing. For example, it's either we can process it through casting, sintering, vapor deposition, doping, joining, annealing, and so on and so forth. So Use the right materials for the job. Understand the relation between property, structure, performance, and processing method. And finally, recognize new design opportunities offered by material selection. Okay, so that will be all for today's lecture. And it is actually the end of chapter 1. So by next week, we are moving to chapter 2. Okay, so that will be all. See you again in the next lecture. Thank you very much for your attention. Okay, bye.